Hi everyone. Today we're going to study RLC circuit. RLC means R, that stands for ohms resistance, L is the inductance, and C is the capacitance. Moreover, we have this R to be the ohms resistor. The L also refers to inductor and C the capacitor respectively. And here are the corresponding symbols. For the unit of measurement, for the ohms, that is for the R, the Henry for the L, and the farads for the C. And the voltage drop are here. For the R, it is R times I. For the L, it is equal to L times di over dt. And the C is equal to Q over C. Let us consider this illustration. By voltage law, we write L plus R plus C equals E. Using the voltage drop formula respectively, the L now becomes L times di over dt plus the R, which is R times I, plus the C, and that is Q over C, all equal to E. We know that Q is equal to the integral of I dt. Let us substitute this value of Q in here. So equation now becomes like this. Let us differentiate with respect to t. The new equation becomes like this. L times second derivative of I with respect to t plus R times di over dt plus 1 over C times I equals dE over dt. We can see here that this is now a non-homogeneous differential equation, and the general solution will be I is equal to complementary function, which is CF plus particular integral, shortened as PI. Let us see this example. Find the current I of t in an RLC circuit with R is equal to 11 ohms, L is equal to 0.1 Henry, C is equal to 10 raised to negative 2 farad, which is connected to a source of EMF. E of t is equal to 110 sine 377t. Assume that current and capacitor charge are 0 when t equals 0. Let us write the differential equation of RLC circuit, and it's here. We consider this to be equation 1. Let us write the given, the R, L, C, and the E of t respectively. Let us substitute these values in equation 1. So equation now becomes like this. We can simplify this 1 over 10 raised to negative 2 as 100 multiplied by I. On the right side, we will take the derivative of this 110 sine 377t, and it becomes 110, the constant, times the 377 times the cosine of 377t. Then we simplify the product, 110 by 377, it will be 41,470. Let us consider this to be equation number 2. This equation number 2 is a non-homogeneous differential equation, and the general solution will be I is equal to CF plus PI. Let's start now by solving for CF. Let us use operators, and we write 0.1 d squared plus 11d plus 100 equals 0. The auxiliary equation is now 0.1 m squared plus 11m plus 100 equals 0. Let us simplify this equation by multiplying by 10. So we have now m squared plus 110m plus 1000 equals 0. Let us solve for m. We can use factoring, and we have this m plus 100 times m plus 10 equals 0. Let us equate both factors to 0. So we have m plus 100 equals 0 and m plus 10 equals 0. So we have this m sub 1 equals negative 100 and m sub 2 equals negative 10. The CF now is like this: C sub 1 times e raised to negative 100t plus C sub 2 times e raised to the negative 10t. Let us copy the CF value in here. Let us write again equation number 2. Then we will solve for pi. Take note that the right side of equation number 2 is regarding cosine function. So the pi will be 1 over f of d times the right hand value. This 1 over f of d is our operators. Let us substitute the values to be like this. Then let us simplify further. We understand that d squared is equal to the negative of a squared. The a value is the coefficient of t in the angle for cosine. So we write here negative of the square of 377. When we simplify this value, we have this negative 142,129. We substitute now the corresponding value in here. Getting the product, we have now this value, and we combine this product with the positive 100 here. And the denominator becomes like this: 11d minus 14,112.9. Next thing to do, we're going to multiply this fraction by the conjugate of the denominator. And this is now the conjugate. We will multiply 1 by the conjugate, and then we multiply this denominator by its conjugate. We will apply the special product formula. So we have this resulting equation. When we simplify this 11d with power 2, we have 121d squared. Again, let us substitute d squared to be negative a squared. That is equal to the negative of the square of 377, and the value is negative 142,129. So it becomes like this. This cosine 377t, we're going to multiply in the numerator here. Let us clear the area on the left. Let us write again the CF value. Then let us represent this expression into like this. We combine all constants in one fraction, and the numerator here we will put as a polynomial. Let us simplify this expression. We can use our calculator to simplify this big fraction. And in here, we can see that this is d cosine of 377t, which means we're going to take the derivative of cosine 377t. On the next line, this constant will be negative 0.0002. When we take the derivative of this expression, we have negative 11 times 377 times the sine of 377t plus this value we will just copy here. Next step, we're going to distribute this negative 0.0002 to the terms inside the grouping symbol. So the pi now becomes like this. By then, we can now put the general solution. I is equal to CF plus PI. The CF value is here and we have derived the PI. So I is equal to this equation. We consider this now to equation number 3. Next thing to do here is to solve for C sub 1 and C sub 2 in our equation number 3. Look at the given, it says t equals 0 when I equals 0. We substitute these values in equation number 3. So equation number 3 becomes like this. Let us simplify the equation. And equation number 3 is further simplified into like this. On this line, we can remove the constant 1 respectively. Also, we can cancel this point. So 0 is equal to C sub 1 plus C sub 2 minus 2.823. We can transpose this negative constant to the left. So equation becomes 2.823 is equal to C sub 1 plus C sub 2, and we can regard this now as equation number 4. Next, let us integrate equation number 3 with respect to t. So it becomes like this. Now, remember that in the given, when t equals 0, the q is equal to the integral of I dt is equal to 0. So when we substitute these values, the equation becomes like this. Let us write again the equation number 3 here. Then we continue simplifying this equation here. The resulting equation becomes like this. When we simplify respective values, the equation becomes 0 is equal to negative 0.01 C sub 1 minus 0.1 C sub 2 minus 0.002. We can transpose these two values to the left side. We have now the 0.01 C sub 1 plus 0.1 C sub 2 equals negative 0.002. This is now equation number 5. Next thing to do here is to solve for equation 4 and 5 so that we will have the values for C sub 1 and C sub 2 respectively. We can use elimination method or substitution method. We will find that C sub 1 is equal to 3.1589 and C sub 2 equals negative 0.3359. We're going to substitute these values in equation number 3. This is our equation number 3. So for the final answer, we will have like this. I hope you learned something from this video. See you again next time.